Welcome viewers to the session of static analysis of beam using Lisa 8.0. In this session, we will be discussing a problem of cantilever beam subjected to a point load at two places. One is 300 mm and another is 200 mm away from the fixed support. So for this, we at least need two elements minimum because at 2 kilonewton one node should also be there. So let us start this problem using Lisa, and for that we have to open the Lisa in our computer. So let us begin the analysis.
Now we will discuss here a beam problem. Now let us perform a static analysis of a beam using Lisa. This is the workspace in three coordinates x, y, z. Click here on z and change it to xy coordinate system. Now go to the analysis static 3D, edit it to static 2D. Now go to new node tab and enter the coordinates. The initial coordinate x is 0, y is 0 and Cartesian coordinate system. Click add here, and the length of this beam is 500 mm. So write here 500 in x and 0 in y and click add. Check here, number of nodes are 2 but the element is 0. To form an element, these nodes should be joined together. So go to new element and type here 1 comma 2, add, close, and now go to fit to screen. This is the element which is having two nodes. Now subdivide this element into number of parts. For this, go to mesh tools, select refine, then custom, and number of subdivision. Under this R it is written 2 here, so change this value. Suppose I want to divide this element into 5 parts, then write here 5 and apply, close. Now this element is divided into 5 parts, means now we have 5 elements. So here it is written 5 elements and total number of nodes are 6. To specify a material for this beam, go to components and material. Here assign new material. In geometric section, choose rectangular bar and write here the values of cross section. In this problem, the height is 100 mm and width is 50 mm. And in mechanical section, choose the material isotropic. Steel is chosen as a material, so the value of Young's modulus is 200 gigapascal, but write the value here in megapascal. So 200 megapascal. Poisson ratio, the value of Poisson ratio is 0.29. Close here. Now select nodes. Select the left end node to provide the constraint here. Go to select faces and here loads and constraints. Click here, new fixed support, and in new fixed support here it's written create from current selection. So this is the current selection, so click OK. Now this end is fixed. Again go to select nodes, Now select the node where the load has to be applied. In the problem, the load has to be applied at a distance of 200 mm. So this is 100 mm, this is 200 mm. So select this node, go to select faces, load and constraints, new force, and x should be 0, z should be 0, but the value of y should be changed because load is in y direction, in downward direction. That's why minus sign should be here. And the load is 2 kilonewton, so right here 2000. It means 2000 newton. Click OK. So it's visible here that load is applied at this point. Again, go to select nodes, select the node which is at the end of the beam, then select faces, go to loads and constraints, new force, and in y apply the load here. Let the load is 5 kilonewton in downward direction. So this is the 5000 newton. Okay. Now material is selected, loads are applied. So this problem is complete. Now solve this problem. So click this solver, and now the problem is solved. Check the values. Displacement in x direction it's 0. The displacement in y direction in millimeter. And the shear force values are here in Newton. Bending moment values in Newton millimeter. And the longitudinal stress values in megapascal. So these are the results, and many results we can see here. Now the next thing is, how can we change the values of load in the same problem when other data is same? Again, go to load and constraints and select force here. And initially we have applied 2 kilonewton force. Suppose I am changing this force to 4 kilonewton. So right here 4 kilonewton and OK. And if I want to change the load which is at the end of the beam, then click here. It was 5000 newton initially. Now suppose I am changing it to 10,000 newton or 10 kilonewton. Click OK. Now the loads are changed. To see the modified results, again we should have to go to solver here. So the problem is solved. Now we can check the values, the displacement in y direction, and the shear force, bending moment, and the stresses, longitudinal stresses in this beam. Okay, now the problem is solved. Thank you.